Hey guys, welcome to the channel Coding Shinobi. So last year I was preparing for my interviews with service based as well as product based companies, and I noticed that most of the interviews were asking similar questions related to Java when it comes to language or the frameworks to test your basic knowledge. So that's why I decided to make this series, and I'm going to cover interview questions topic by topic, and today's topic is JVM. So let's deep dive into this. There are very less questions related to JVM, but whatever the questions that I have covered in this series, these are most important questions, and you can expect them in your interviews. So let's start with the questions now. The first and foremost question is obviously what is JVM? Most of you guys might know answer for this, but still, since I'm making this video, I'm bound to explain you this as well, right? JVM is nothing but Java Virtual Machine. The name itself suggests that it provides an environment or virtual environment to run your Java programs. It basically converts the bytecodes to machine specific code. When you write a Java program and compile it, the compiler creates a bytecode file, a class file which contains the bytecode. But it is JVM's responsibility to convert that bytecode into machine specific code. Also, as developers, we use JVM to manage and optimize program memory and run Java program on any device or operating system. So this is one of the reasons like why Java is machine independent or platform independent. You can run your Java program on any operating system. So this basically gives you another question: how is Java programming language independent of machines and platforms? So, guys, you have been hearing these things like Java is machine independent language or operating system independent language. What does that mean? When you compile a code in Java, a class file is created containing a bytecode, and that bytecode is machine and platform independent. JVM interprets this bytecode and executes Java program. When you are downloading JVM from its official website, like Oracle's official website, then you have to select like which operating system you need to install your JDK on, right? It is JVM's developers' responsibility to convert that bytecode into a machine specific code. The bytecode is converted to a machine code, and that machine code is specific to the operating system like Windows or Linux. And that is Oracle's responsibility, or that code has been written by Oracle to translate that bytecode into machine specific code. Okay, that's why if you compile your code on Windows, a bytecode is generated, a class file is generated, but when you run it on Linux, the program will run perfectly. Now, this is most frequently asked question I can say. You can, if you are getting asked questions on JVM or JVM related stuff, then 99% you can expect this question from interviewer. Like, what is JRE and JDK, and what is difference between them? And the answer is JRE basically stands for Java Runtime Environment. JDK stands for Java Development Kit. JRE is a software package that includes JVM Java class libraries and a Java application launcher. JRE's responsibility is not to compile the classes or to create a class file. Right? It is in fact JDK's responsibility, because JDK includes JRE compiler and debugger and other tools that are needed to develop Java applications. So, if you want to write a Java code and compile it, you need to have JDK installed. And if you just want to run your class files, then JRE is enough. So, this diagram basically sums up what is the difference between JDK, JRE, and JVM. The JRE is a part of JDK, and JVM is a part of JRE. Let's move on to the next question. What is JIT compilation and how does it improve performance? This question is not as important, but we might as well have knowledge about it, right? The JIT, or just in time compilation, is a technique used by JVM to improve performance by dynamically translating bytecode into native machine code at runtime. And the frequently executed code paths are optimized for the specific hardware architecture, resulting in faster execution and reduced overhead. That's why this is how it improves the performance. Now, can JVM handle native code integration? If yes, then how? Yes, JVM can handle native code integration. It is through native method interface called as JNI. It allows us to call native methods written in C or C++ languages. Um, And also it enables user to have a smooth experience when integrating it with the native methods or existing libraries that are written in C or C++. It so basically you can use existing libraries that are written in your native languages, and you don't have to rewrite those libraries again. Explain Java memory areas. If you look at this diagram, you just need to explain this five memory areas that you can see in this diagram. And it is good to explain class loaded to the interviewer if you are aware of the what is class loaded. But in this answer, we are going to cover class loaded as well. Let's start with the class loader itself. Of course, as the name suggests, class loader is used to load class files into JVM and is a part of JRE. So not all class loaders are loaded by single class loader. Depending on the type of classes and the path of class, the class loader that loads the class is decided. Java class loader is of three types. First, bootstrap class loader. Second, extension class loader. Third, system class loader, also known as application class loader. Let's start with bootstrap. Bootstrap class loader is a machine code which kickstarts the application when JVM calls it. It is not a Java class. It loads all the classes from rt.jar location, and also known as primordial class loader since it does not have any. Second one is extension class loader, which is a child of bootstrap class loader. It loads the extensions of core Java classes from respective JDK extension library. Loads from files from this mentioned directory or any other directory pointed by system property. You don't need to remember this property names. Having knowledge that it loads extensions from some directory is enough. If any case in future you need to modify it, you can always Google it, right? The last type of class loader is system class loader, which is also known as application class loaders. It loads application type classes found in environment variable class path. You all might be aware with the class path environment variable which we set while we are installing the JDK. It will basically scan all the class files in that particular path location, and it will, if the class is found, it will load into memory. It is a child of extension class loader. Now comes the main answer, like types of memory areas. There are, as we have seen in the diagram, there are five main memory areas when it comes to Java. First one is class or method area. It is a memory block that stores the class code or your method code and variable code and the constructor of Java program. It basically stores your class template in class area. Also stores class level data of every class such as the runtime, constant pool, field and method data, the code for method. The second one is heap. And this is one of the important because whenever you create an object with a new keyword in Java, all these objects are stored in heap. It allocates memory at runtime, and it also allocates memory for classes, class interfaces, and arrays. Arrays is considered as object in Java. And also, you must note that before Java, its static variables and methods were stored in class area, but in recent versions after Java, its static variables and methods are stored in heap memory. Third one is stack. Each thread has private JVM stack created at the same time as thread. It is used to store data and partial results which will be needed while returning value for method. And you all know that method calls are stored in stack, right? So the data is stored in each frame of stack related to that particular method and method call. And once a method execution is completed, the frame is removed or destroyed from stack. You'll see in this diagram, each stack frame, it contains the local variable array, operand, stack, frame data as in the method, the data related to method. If you have worked with recursion, you might know what a method stack is. Now let's move to the fourth memory area, which is program counter register. A JVM thread that carries out the task of specific method as a PC register associated with it. It stores the return address or native pointer on some specific platform. So when a method call is made, if that method execution is completed, it should know where to return, right? So the return address and all the stuff, it is stored in program counter register. Fifth one is native method stacks, also called as C stacks. Of course, they are not written in Java language. They're allocated for each thread when it's created. This native method stacks is basically stack area for native methods, and it can be fixed or dynamic in nature. What are the key features of class loader? As we have already discussed what a class loader is and types of class loaders, you can tell it to the interview, like you can start with what is class loader, and then you can tell the types and describe in brief what all the three types of class loaders are. And further, you can add the features of class loader. So there are basic three main features of class loader: delegation model, visibility principle, and uniqueness property. JVM and class loader uses an algorithm called delegation hierarchy algorithm to load the classes. Whenever JVM comes across a class, it checks whether the class is already loaded or not. If loaded, JVM proceeds with execution. If the class is not present in the method area, then JVM asks the Java class loader subsystem to load that particular class. Then a class loader subsystem hands over the control to the application class loader. Then application class loader delegates the request to extension, and extension further delegates it to the bootstrap class loader. Bootstrap class loader will search in the path that I have mentioned here, JDK JRE, in its library. It will search for that class in its library. If the class is found, then it will load the class. If the class is not found, then it will delegate the request to extension class loader. The extension class loader will search for the class in its extension libraries. If the class is found, then the class is loaded in JVM. Otherwise, the request is delegated to application class loader. Application class loader then again searches in its application class path. If the class is found, then the class is loaded, and if not found, class not found exception is thrown. Visibility principle states that class loaded by parent class loader is visible to child class loader, but a class loaded by child class loader is not visible to parent class loader. Of course, when application class loader gets a request, it is first delegated to Bootstrap, right? If Bootstrap is loading a class into JVM, then of course the child class loaders know that this class was loaded by our parent. But if a child class, like application class loader, loads a class, then Bootstrap class loader has no idea of such classes. And the third feature is like uniqueness properties. It will ensure that classes are unique and there is no repetition of classes. Of course, right? Like first Bootstrap will check search, then extension will search in its path, and then application will first. It will make sure like no classes are repeated. Also ensures that classes are loaded by parent class folder and not again loaded by child class folder. If the parent loader isn't able to find the class, then only current instance would able to do it itself. So this information is enough about class loader. Even if you don't know, like just remember the delegation model. You can't remember everything, just know the delegation model. And delegation model is related to the three bootstrap class loaders, and it just maintains the hierarchy between them. If you even know these things, it is more than enough to tell the interviewer. It should be fine. So this is all about JVM interview questions. This is the first video in interview Java interview question series. But if you have any topic relate in your mind that needs to be covered, do let me know in the comment section. Uh, and also, if you have any more questions, you can write it in comments section, and I'll try to answer them. Answer everything. Thanks for watching. If you do like the content, do hit the like button and share the video with your friends. Thank you.